This is an adaptation of a blog post I wrote back in 2018. The link to the original text version will be in the video description. I've been watching several YouTube videos about the universe lately. The vastness of space is nothing short of mind-boggling. Astronomical distances are almost impossible to wrap my head around. To get some idea of what I'm talking about, take a look at the real-life lore video, How the Universe is Way Bigger Than You Think. But that's not quite what I'm here to talk about today. I've come up with an example to demonstrate the scale of the area of space closest to home. Have you ever noticed how scale models or drawings of the solar system tend to accurately depict either the size of the planets or the distances of their orbits, but never both? Well, I've been reading up on it, and I've decided to demonstrate what would happen if you did try to account for both. Now, I better clarify a few things before we start. Firstly, I'm only going to cover the 8 planets, and obviously the Sun. The solar system extends far beyond Neptune, and it includes several dwarf planets, most notably Pluto. But for reasons that will later become obvious, I'm only including the 8 main planets orbiting the Sun. I can't include everything. Also, judging each planet's distance from the Sun is a bit complicated. A planet's closest position to the star is called its perihelion, and the opposite is called the aphelion. Because no planet's orbit is a perfect circle, there tends to be a difference of several thousand kilometers between the two. So to keep it simple, I'll be going by each planet's average orbital distance. The scale that I've decided on is 1 millimeter for every 10,000 kilometers. Let that sink in for just a moment. So now let's see where that scale takes us. Here we go. Let's imagine all the planets have lined up. We'll start with the Sun at one end and work our way outwards from there. In real life, the Sun is about 1,391,400 kilometers in diameter, over 3 times the size of all 8 planets combined. On our scale, that's about 13.91 centimeters. So if you can find a ball that's about the width of 2 tennis balls, there's your stand-in for the Sun. Mercury, with its real-life diameter of only 4,879 kilometers, would be less than half a millimeter wide on our model. That's the size of a dot made by a ballpoint pen. This tiny, almost invisible pinprick would be placed at a distance of 5.79 meters from our 14-centimeter ball representing the Sun. That may not sound like much, but you could easily fit a pickup truck into that distance. And that's only the first planet. Venus would be 1.21 millimeters across and placed 10.82 meters away from the Sun, which is roughly the length of a double-decker bus. Earth wouldn't be significantly bigger than Venus at 1.28 millimeters across. It would be 14.96 meters away from the Sun. Mars would measure 0.68 millimeters on our scale and would be separated from the Sun by 22.8 meters. Wow, we've only seen the 4 inner planets so far on a scale where they're no bigger than pinheads, and we've already covered the length of a tennis court. Jupiter is about 1.43 centimeters in diameter. It's the biggest planet in the solar system, and yet it's still smaller than a penny on this scale. Our model puts its distance from the Sun at 77.86 meters. That's longer than a Boeing 747 jumbo jet. Saturn is 1.2 centimeters across, not counting the rings. At this point, we've crossed the billion-kilometer mark, or in our case, the 100-meter mark. Saturn is 143.35 meters away from our Sun. Uranus is 5.11 millimeters wide, just over half a centimeter, and 287.5 meters away from our Sun. And finally, Neptune. It too is about 0.5 centimeters in diameter, and its distance from the Sun on our model is exactly 450 meters. That's longer than the height of the Empire State Building. So in total, our scale model of the solar system has covered almost half a kilometer of ground, and yet even the biggest planet, not counting the Sun, is no wider than the head of a thumbtack. I'm sure now you understand why a model of the solar system that's completely to scale would be next to impossible.